notes on section 1.2, mathematical patterns, and this is the first set of notes in that section on defining sequence. Make sure that you have the student objective in your notes. Students will be able to define sequence, sequence notation, and recursive functions. Make sure that you have the definition of sequence in your notes and ordered list of numbers. Make sure that you have the definition of term in your notes, each number in the list. And make sure that this example problem is in your notes. Pause the video. Here's your example problem. Pause the video, make sure everything is written, and then hit play again so that we can answer the questions together. Okay, what is the first term? All right, well, that's the first number in the list. In this case, the first term is -4. What is the sixth term? Well, we're just going to count them, okay? So this is the first, second, third, fourth, fifth, sixth term. So the sixth term is 11. And what is the seventh term? Okay, well, in order to determine the seventh term, you have to be able to figure out what the pattern is so you can make an educated, I guess. So in between -4 and -1 is you add 3. Okay, well, let's see, do you add 3 to get to the next term? -1 plus 3 is 2, and 2 plus 3 is 5, and 5 plus 3 is 8, and 8 plus 3 is 11. All right, so it seems that the pattern is you take the previous term, you add 3 to get the next term. So 11 plus 3 is 14, and therefore the seventh term in this sequence is 14. All right, here's the definition of infinite sequence. An infinite sequence has an infinite number of terms. So this ... tells you that the same pattern follows for forever. Okay, and so that makes this sequence infinite. Make sure you write down definition of infinite sequence, write down the example, and then see if you can't answer these two questions, the first two questions, on your own. And then we'll talk about the nth term. Well, we're going to talk about all three of them together, but I want you to try the first two on your own. Okay, 2, 4, 6, 8, 10, 12. It looks as though we are adding 2 every time to get the next term. So 2 more than 12 would be 14. Okay. What's the 10th term? All right, let me count them again. Here's the first, second, third, fourth, fifth, sixth, seventh, all right, 8th, 9th, 10th. Okay. So we know that the 7th term was 14. 2 more would be 16, 2 more would be 18, 2 more would be 20. So the 10th term is 20. Okay. The question, what is the nth term? This might feel a little bit awkward. What is the nth term? Nth is a variable, so you substitute the letter n in for whichever number. So if I were to come to some unknown numbered term, how can I write an algebraic expression that gives that term? So if you take a look at the relationship between the term number and the term itself, there's a different pattern. So if you multiply the term number by 2, you get that term. So the nth term would be 2n. So that describes the term in relationship to the term number. Okay. This you should be able to try by yourself. There's nothing difficult here. Pause the video, give it a try. Okay. Now this one is not adding. the same number every time. It does look, if you ignore the signs, that you're adding 2 to get the next term. But we have also got something going on where we are changing the signs. We're alternating them between positive and negative. So the next term, without the sign, well, let's look at the sign first. This one's a negative, and this one's a positive. So we're alternating. The next one will be negative. And then we're going 2 more for each term. So 13 plus 2 is 15. So the next term is negative 15. All right, what's the 10th? Again, I'll count them. So I've got 1, 2, 3, 4, 5, 6. All right, so 6 is negative 11. 7 is positive 13. 8 would be negative 15. 9 would be positive 17. And 10 would be, it's not letting me change color, 10 would be negative 19. There we go. So the 10th term is negative 19. Another example, this one has fractions. Okay. Again, I know you get scared when you see fractions, but pause this and try this to see if you can figure it out yourself, and then listen to my solution. All right, so again, I want to number my terms here to start understanding this. I've got term 1, term 2, term 3, term 4, term 5, 6, 7. All right. And let's see, most of these terms are fractions, but the first 2 are not. So what if I were to write them in fraction form? So this is 2 over 1, okay? And this one's 1 over 1. All right. Now look at each of these terms that start with a fraction. So here I've got a denominator of 3, right here. I've got a term number of 3 and a denominator of 3, a term number of 4, and a denominator of 4, a term number of 5, and a denominator of 5, term number of 6, and a denominator of 6, okay? So let's think about this, all right? Even the first term is 1 over 1, okay? What if this was 2 over 2, okay? What does 2 over 2 equal? 2 over 2 equals 1, all right? So yes, the denominator is following the pattern of the term number. The numerator is always 2, right? What's the next term would be 2 over 8. What's the 10th term? 2 over 10. And what's the nth term? 2 over n. Okay. Continue the pattern by drawing the next 2 diagrams and write an infinite sequence that represents the number of stars in each diagram. Again, pause this, try this by yourself. Okay, I'm going to give this a try. The first row has 1 star here, 1 star here. I'm going to pause this to see if I can line this up a little better. Okay, I paused and made some adjustments. Let's see if this works out a little bit better. So I've got 1 and 1 star, and then I've got 3 and 2, and then I've got 5 and 3. So this column is always the same number as the term number, okay? The second column is always the same as the term number. And then the first column is always 2 more than the previous in that column. So the 4th term is going to have 4 stars in the right column, and it's going to have, well, the previous one had 5, so it's going to have 7 stars. One, two, three, 4, 5, 6, 7. Okay. See if I have room to do the next one. Scroll up a little bit. All right, so in the next one, we are going to have 5 stars in the right column and 2 more than 7. So I'm going to have 9 in the left column. Okay. So total number of stars is 2. 3 plus 2 is 5. 5 plus 3 is 8. Okay. Here I had 7 plus 4 is 11. Okay, and here I had, this was 11 plus 5 is, hold on, or did I? 1, 2, 3, 7, this should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I have too many stars. 2 more than 7. Okay, so I messed up that last column, forgive me. So this should be 9 and 5 makes 14. All right, so now just look at the numbers that are in red, 2, 5, 8, 11, 14. You are always adding 3 to the previous term. Okay, same sequence, 2, 5, 8, 11, 14. Now here is a new notation. U sub 1, that means the first term. U sub 1 means the first term. Okay. U sub 2 is the second term. If you're writing this out, the number 2 is in subscript. It's small and to the right of U. U is the variable. And then the term number is the subscript. Okay, this is a new way of writing a sequence. And so each term is given a term number by the variable name. Now, the nth term in this sequence could be defined as, and then this is called recursive form of the sequence, okay? And what that says is that the nth term, okay, that's the nth term. We don't know what the term number is. We call it n. The nth term is equal to the term that comes before it. You subtract 1 from n. So whatever the term that comes before that is called the u sub n minus 1 term. And then you add 3 to the previous term, all right, blue that I circled is the previous term. Okay, you add 3 to the previous term. All right, and that's what it says here in the English. Make sure that you have this written down. Pause the video before you move on. Okay, the next slide is in the X column is the term number, and in the Y column is the term. This is the exact same sequence we've been working on since we started with the stars, and those numbers can be found in the Y column. The X column is the term number. So if we can write these as XYs, then we can write them as an ordered pair. All right, this machine will only allow me to record 15 minutes. I'm getting there, so this is going to be it for our first video.